Students, this is sampling and reconstruction trainer. So in this practical we will learn that if we are given any signal, if we want to discretize it, if we want to make it discrete in time, we need to do the sampling. Okay, so sampling is done on any given analog signal. So over here there is a block which will generate the analog signal of 1 kilohertz, which we will take from here. I am pointing out over here. Then what we will do is we will give this signal to the sampling circuit over here. So this block is your sampling circuit. After the sampling we will give it to the sampling amplifier, and we will see the sample version over here in the sampled output. There is another category which is called sampled and hold, which will hold the previous value of the sample. So there is a capacitor which will be charged and it will hold the previous sample value. Now once we get this sampled output, okay, suppose we want to reconstruct it, then we need to pass it through a low pass filter. So over here, for understanding purpose or for learning purpose, they have given two blocks. Okay, one is second order low pass filter. Definitely we can reconstruct our sample output from second order low pass filter, and we can see the output. Whatever the output of the second order low pass filter, which will behave as a reconstruction block. So whatever input you have given, that 1 kilohertz, that should be coming over here. But as it is a second order low pass filter, you will not observe the perfect, you can say, the wave which was given in the sampling. Now another option which is given in the kit is the fourth order low pass filter. Students, this is sampling and reconstruction trainer. So in this practical we will learn that if we are given any signal, if we want to discretize it, if we want to make it discrete in time, we need to do the sampling. Okay, so sampling is done on any given analog signal. So over here there is a block which will generate the analog signal of 1 kilohertz, which we will take from here. I am pointing out over here. Then what we will do is we will give this signal to the sampling circuit over here. So this block is your sampling circuit. After the sampling we will give it to the sampling amplifier, and we will see the sample version over here in the sampled output. There is another category which is called sampled and hold, which will hold the previous value of the sample. So there is a capacitor which will be charged and it will hold the previous sample value. Now once we get this sampled output, okay, suppose we want to reconstruct it, then we need to pass it through a low pass filter. So over here, for understanding purpose or for learning purpose, they have given two blocks. Okay, one is second order low pass filter. Definitely we can reconstruct our sample output from second order low pass filter, and we can see the output. Whatever the output of the second order low pass filter, which will behave as a reconstruction block. So whatever input you have given, that 1 kilohertz, that should be coming over here. But as it is a second order low pass filter, you will not observe the perfect, you can say, the wave which was given in the sampling. Now another option which is given in the kit is the fourth order low pass filter. So as we have explained earlier, okay, there are various blocks in the sampling and reconstruction trainer. Now this one is the different, these are the different frequencies which we can choose. So as you can see, there are various frequencies like 320 megahertz, 180 megahertz, 320 kilohertz, 180 kilohertz, 80 kilohertz, 160 kilohertz, 80 kilohertz, 40 kilohertz, 20 kilohertz, and 10 kilohertz. Okay, so any sampling frequency we can choose. Okay, so we can choose by pressing this button. Okay, so I am pressing this button once, so that sampling frequency will change. Pause. This press button, okay, I will be able to change the sampling frequency. As you can see, it is moving. Okay, so whichever you want to choose, you can choose. So now I will show you the waveform for the first sampling frequency which we have chosen, that is 10 kilohertz. That is 20 kilohertz. Okay, right now. So let's see the waveform for. So this is the waveform for the first, you can say, 20 kilohertz sampling frequency, and our original signal, which will be, I will be showing you. So we are going to sample. So on the CR now, kit I am showing you the input waveform. Okay, this waveform is the 1 kilohertz sine wave which is to be sampled. Okay, so this is 1 kilohertz sine wave. Okay, now this I have given into the input of the sampling block. I have given input to the sampling block. Okay, so over here the sampling will be done and output will be available at this point. Okay, so just I will be connecting the output pin over here. Okay, so I will be seeing the sampled version, so which you can see on the CRO. Okay, now I will be Now I have changed the sampling frequency to the 40 kilohertz. Now we will see the waveform, sampled waveform for 40 kilohertz. Okay, so as you can see, there are more sample compared to the 20 kilohertz. Number of samples are doubled. Now again I will change the sampling frequency. So now you just see the LED which will be moved to 80 kilohertz. Okay, now we will see the waveform again. Okay, so it is having more sample compared to the previous one. Again I will increase the sampling frequency to 160. Now you see the waveform. So there are more samples as you can see. Okay, again I will be changing the sampling frequency to 320 kilohertz. So you can see this is the highest frequency available on the kit. Okay, so there are more samples you can see over here. Okay, so these are the sampled waveform. Okay, now what I want to do is I want to show you the sampled and hold waveform. Okay, so now I am moving on to the kit. This is sampled signal. Okay, now I want to see the sample and hold. So what is sampled and hold? The sampled value which will be holded. Okay, so you will see the waveform like this, which you can observe onto the CRO. So these are the holded sample value. Okay, now I will decrease the sampling frequency. Again, right now it is 320 kilohertz. Now I will make it, let's say, 160 kilohertz. So you will see the sample and hold waveform, how it looks like. Again I will be decreasing the frequency to 80 kilohertz. So now you can see the sampled and hold waveform. Okay, now again I will decrease it to 40 kilohertz. Okay, so you see the output waveform for this. Okay, now I will decrease again to 20 kilohertz. Okay, now you see the waveform. Okay, so these are the sampled and hold value. Okay, now friends, these are the sampled signal. Now I want to reconstruct it. Okay, so for reconstruction, as I explained earlier, we have to pass it to the low pass filter. Okay, so now I will go to this block of low pass filter for reconstruction. So whatever output I have available, which is the sampled version, okay, now I will give input to the low pass filter and I will try to observe the output at this point. Pause. Hello. So this second order low pass filter's output I am connecting with the CRO's output pin. Okay, so whatever the reconstructed output, that will be seen in the CRO right now. Okay, so as you can see, it is not perfect sine wave which we have given in the input, because it is second order low pass filter, as well as the sampling frequency which we have utilized is less. Okay, now if I increase the sampling frequency, what is the effect on the reconstructed waveform, that we will see. Okay, so now I am increasing the sampling frequency. Okay, so I am making it 40 kilohertz. Okay, so my sampling frequency has increased, so reconstructed wave will be better. Okay, now again I am increasing the sampling frequency. Okay, so it is now 80 kilohertz. So reconstructed wave will be better compared to the previous one. Okay, again it is let me make it highest 320 kilohertz, and the second order low pass filter is reconstructing, so you can see approximately the original sine wave kind of thing, but it is not perfect. As you can see, there are some small variations which are coming. Okay, so this is, you can see the output. Okay, now this is second order low pass reconstruction. Okay, if I do fourth order low pass reconstruction, then the output will be quite better compared to the first or second order low pass filter. So the frequency is highest, so I am getting the perfect sine wave. Okay, but if I decrease the frequency, Okay, so let me decrease the frequency to 20 kilohertz. Now we will see the waveform. In this waveform you can observe that it is not perfect sine wave. So as I am going to increase the sampling frequency, okay, my waveform will be improved in the reconstruction. Okay, now this is 80 kilohertz sampling frequency. As you can see, I am getting a good sine wave, but it is somewhat distorted in the peaks. Okay, now again I am making it 160, so it will be good compared to the previous one. So now you can see almost very good sine wave I am getting in the output. So this is the output of the fourth order low pass filter. Okay, so it is better. Now the output of sampled and hold will be still better compared to the, you can say, only sampled. Okay, so sampled and hold circuit for 20 kilohertz output, if I am showing you, then it is this kind of output which is better compared to the sampled one. Okay, now again I am increasing the sampling frequency, then you can see at 80 kilohertz I am getting the perfect sine wave in the sampled and hold. So compared to sampled and hold output is better for the reconstruction. Now if I want to make it sixth order low pass filter, then what I should do is this sampled output I am connecting into the second order low pass filter. Okay, so this is my second order low pass filter. Second order low pass filter will be, output will be connected to the input of the fourth order low pass filter. So this is second plus fourth, so this is now sixth order low pass filter. So even for the less frequency we will be getting the good output. So let's say if I am making it 20 kilohertz, okay, then my output will be like this in the normal sampled version. Okay, now if I am making it 40 kilohertz, okay, now we will see the output. Okay, so it is a kind of perfect sine wave which we are getting because the sixth order low pass filter will be reconstructing well. So what we learned is, as we increase the sampling frequency, reconstruction is better. Second thing, if we increase the order of the filter, then reconstruction will be better. Third thing, if we use the sample and hold waveform for the reconstruction, then the reconstruction will be better. So these are the learning from this practical. Okay, thank you.